Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night in-depth ag forecast brought to you by Nutrien Ag Solutions. Well, in a video I released this morning, I got a great question. I think we should just spend some time trying to answer that question because it's going to fit in nicely with us trying to decipher what this new long-range outlook is going to look like. So the question was, well, all the models keep showing that La Niña is going to start to fade after the beginning of the new year. Why? Why are they showing that? And I just want to tell you something. That's a tough question to answer. There's so many different factors that influence the trade winds and why they're behaving the way they're behaving. But what we're going to do is we're going to look at one of those triggers today. All right. So you've been looking here at a graphic that shows you back to 1950, every El Nino event, these are the big spikes up, and every La Nina event, the big spikes down. As we've talked about many times, a lot of La Niñas are these double dippers. They kind of come in pairs. Okay. There's been a few times where we've seen three of them, like 98 to 99, 99 2000, and then 2000 into 2001, although that one was steadily fading as it went forward with time. So where we currently stand is right over here on the graphic. So this was the La Niña that peaked last winter. We then had, that would be the winter 20 into 2021. Then we had the one that went into 21 into 2022, and then now we're currently here starting our third La Niña event this fall. So we have questions as to whether or not it's going to continue to last. And the bigger question was, what's the trigger? What starts to change in the atmosphere? And so I'm going to show you one of those triggers today that starts to just get us thinking that this La Niña may start to fade. And to do that, I want to take you deep into the atmosphere. In fact, I want to take you to the stratosphere. We're going to look at something called the Quasi-Biennial Oscillation. I've brought it up a few times over the years. It's a bit of a difficult topic for even me to fully grasp what it means. And so therefore, it's challenging to explain. But I just want to show you something. Going back to 1980, looking through the depth of the atmosphere. So this is 300 millibars. Okay, so that's the top of the troposphere into the stratosphere where the pressure is 10 millibars. So this is a stratospheric event. What we see is this oscillation between more westerly dominated winds versus easterly dominated winds around the equator. And they just kind of come in an interesting and regular interval, but there are some year-to-year differences. Now, first thing I want to point out is nearly every time we have an El Nino signal, like we had in 15 and 16 and 17, we had more of a westerly dominated QBO. Can you see that? Whenever we've had La Niña, we tend to have more of an easterly dominated. Let me give you a couple examples. In 2020 into 2021, do you see this here? The westerly switchover was weak. What about 2010, 2011? See it? The westerly was brief and then the easterlies came back. What about 97, 98? You can see that the westerly interlude was brief and we saw a very strong return to these easterly winds going into 2000, 2001. So you see, that's one of the clues. It's all about the full atmospheric motion and its net progression with a westerly component because the direction the Earth spins. So we're always measuring the relative velocity of the atmosphere to the Earth's rotation. And there is a constant redistribution of heat that's happening underneath that forward motion in Earth's spin. And that's where the equator takes on more heat and moves it toward the poles. So ultimately, this is all about understanding the differences in temperature, but we often see the kinematic effect of that, the wind effect of that, by looking at some big wind patterns. And so let me give you an example. The first ones we're going to look at here, this was on the January 1st, 2017. So on January 1st, 2017, right here, you can see we had a strong westerly component to the wind. So what you notice is that right here along the equator and just north of it, we noticed that there was no easterly bias to this. Do you see that? Versus if I just go a year ahead, so from here to here, January 1, 2018, look at the difference. So here's 2017 and there's 2018. So normally when we have the QBO in its normal phase, it has an easterly component to the wind here. This again is related to the temperature redistribution of Earth, and Earth's rotation. But when we get a westerly component like this we saw in 2017, it's gone. Now what I'm trying to tell you is this. For the last few years, any sense of a westerly component to the wind has been very brief, and it's been pretty far down in the atmosphere, in the stratosphere. We've maintained more of that easterly component, and it keeps coming back at certain times. What the models are starting to see is the upper level winds have started to really develop a pretty strong westerly component, and the forecast is for that to continue. Now, there will be an atmospheric response to all of this, and what we'll likely see will show up in the vertical and zonal integral, or just integrating, adding up the total atmospheric angular momentum. Now, usually when there's a La Niña, you see a lot of these blue-greens, slower momentum. That's what allows the atmosphere to get blocked. That's what makes La Niñas so dangerous for the United States with respect to drought, especially in the mid part of the country. When there's an El Niño, we tend to have a higher atmospheric momentum, especially in the jet stream level winds. That's where you would see a lot more of these, warmer colors, especially here across this range between 30 north and 60 north. That's where our jet stream lives. We don't have that right now. See that? We're in a low momentum state, especially in the northern hemisphere. And the reason for that is we have a La Niña right now. But as I've brought up here at the beginning of the video, the questions are about, will it continue and will it last? Now, I've made a statement in several videos in a row that while we have continued to see very cold water showing up here, the thing that will be the trigger for me to know when this La Niña is letting go is going to be in these Hofmüller diagrams. You know that this is today, and we're going forward in time all the way to the 21st. And the blue-greens here stack up right on top of the diagram right down here and represent strong trade winds in that direction. We still have strong westerly wind bursts coming out of the Indian Ocean. And so if you ever asked an atmospheric scientist, what's the key to knowing whether or not the atmosphere is truly behaving like a La Niña? It's right here. This is what the atmosphere is doing. That produces an MJO phase 5, where we've been talking about how that's going to help really add momentum to the Pacific jet as we get into the end of this month and into November. So with all of that kind of tucked away in the back, this is the new update from October 20th to November 20th. And what you're starting to see is the model keeps producing above normal precipitation in the west and possibly more frequent storm systems coming through the midsection of the country, while from Texas to the Carolinas, maybe a drier bias. And what I would tell you is this look from October 20 to November 20 is very characteristic when you have a La Niña, especially as one as strong as we have right now. So this is your newest European Weeklies forecast. The precipitation pattern I buy into, I think that this is, just based on history, this is going to be accurate. What I don't agree with is the 30-day outlook for temperatures. I think you're seeing this, at least I would, seeing this as being, just favoring much above average temperatures in this area for a while. And what I'm going to make a statement about is I've seen the atmosphere block up quite a bit in the Gulf of Alaska, sending a lot of the flow over the top like this, giving us these repeated shots at cooler air, especially through the next 15 days. So I think this has got too much of a warm bias going forward. Doesn't mean we won't see warm days. I just think it's got too much of a warm bias. Now, that original question we started with is, how long does this last, and how do the models know it's transition? Because we've seen that one of the best models we have in the US, the CFS V2, consistently showing La Niña strengthening in October, probably peaking at some point in October or November, and then in December through January starting to fade back into neutral conditions, which are right in through here. This has now been echoed by the brand new long-range update from the European model just released last night. Its forecast for ocean temperatures in Niña region 3.4. That's the same thing seen here. And just a reminder, Niña region 3.4 is this spot. So when these cool waters go away, that tells me the trade winds have backed off and the warm water comes sloshing back. So that's the indicators here of La Niña ending. So you notice that the forecast in that area is to bring the temperatures back up toward neutral, especially as we get towards spring. Now the reality of this is that it's a nonlinear chaotic system. So while we see these indicators today, and that's what's guiding my forecast, understand that there are things that can always change. For example, last January, I thought the La Niña was going to fade by summer, and it did not do that. And sure, we can look back and diagnose why. Certainly the easterly winds in the QBO were part of that. But I just want you to know that this is just based on the evidence I've got up to this point. Now, just as a reminder, if we go into winter and we have a La Niña, versus an El Niño, when you look back over the last 70 years of data, these data, we can then reconstruct what the atmosphere most likely would do. So when there's a La Niña, the jet stream likes to run up through the Gulf of Alaska, around a blocking high here, and then dive through the northern tier of the U.S. So this increases the rainfall in the northwest and tends to keep the Ohio River Valley active with storms. because of a lack of a subtropical component of the jet. That's the one that comes from Hawaii toward the U.S. We tend to be drier from California through Texas all the way through the southeast. When there's an El Nino, we tend to have a more variable North Pacific jet and a stronger, more extended subtropical branch of the jet stream. So this is why in California, we often desire El Nino so much, because it is the pattern that gives us subtropical jet that returns the moisture. We tend to be warmer to the north. Absent any major fluctuations in the polar vortex, it just tends to be warmer north. And the Ohio River Valley tends to be drier. What we're seeing in the models is we're likely going to start with this pattern and start to move toward the development of a subtropical jet going forward. Now, internationally, just something to think about here, this is what we see when there is an El Nino and rainfall and a La Nina and rainfall. And so some of the things we've been discussing here about South America favoring wetter conditions north and drier conditions in Argentina, again, that's based off of the historical evidence. So just kind of showing you a few of these different pieces. We can then make correlation maps. We have data going back to 1948. And so what we can do is we can look at every time there was cold water in the central equatorial Pacific and make a map correlating it against precipitation. And as you look at these, and we've looked at them before, the blue colors represent wetter when there's a La Nina, and the red colors represent drier when there's a La Nina for December to February. So you can see how the jet comes in like this, comes over the mountains, produces a rain shadow, and then ejects through the Ohio River Valley. Now, if you were to have an El Nino, the red colors would mean wet, and the blue colors would mean dry. And in that case, the subtropical jet comes in like this, making it wet from California through the central United States, from Texas over to the East Coast. That's the difference, and that's the setup. So I'm telling you all of this because we had the new long-range data just released. So what we're going to look at is a 3-month sliding window of precipitation anomalies. So this is what October, November, December looks like. And a lot of this is biased pretty heavily toward right now. Seeing the drier conditions here, still the moisture pulling into the Four Corner states, and what we expect to see in November for the Pacific Northwest. But as we go forward into November, December, January, and then December, January, February, this look is almost a textbook La Nina outlook for the start of winter, right? Wetter Northwest, active storm track through the northern tier of the United States, active storm track through the Ohio River Valley, drier south. But what we get after this is that the models in January, February, March, and then to February, March, and April are now favoring much more green on the map. And what that indicates to us is that we're starting to see maybe better evidence of this pattern shift. And why I care so much about it is because of this. This is our latest drought monitor. And anything we can get the jet stream to do this winter to deliver more precipitation will work hard on reducing drought area, because there's really only 2 preseason indicators that we have at our disposal to forecast an upcoming season. Ocean temperatures, which now you know why, and then what the current soil moisture is, because it takes a long time to really change deep soil moisture. So before we go any farther, I want to come back to this. I'm going to show you a couple other things. How about we go down to South America? La Ninas in South America tend to produce, as we saw on the graphic, wetter conditions north and drier conditions south, and we're seeing that right now. I mean, Argentina's struggling with drought, pockets of southern Brazil are as well. The new forecast for the rest of planting and the beginning of the growing season is to maintain a wetter bias north and risk drier conditions south. As we go forward into November, December, January, February, that dry risk continues to stay there while the La Nina keeps its grip. But as we switch crops from the first crop of beans over to the second crop or safrinha crop of corn, the model did do something quite interesting for January, February, March, and then February, March, April. And that was to reintroduce drier risk here when the safrinha crop goes in. So I'm going to have to watch that carefully. You also know we're dealing with substantial drought happening right now in China. And if we go over to Asia, you can see that it continues to forecast. Just keep your eye here. This is where the drought currently is. And as we slide forward, going through winter, we notice that all the way out to the start of spring, the models continue to keep that region dry. It will all be about the setup of what's called the Mayu front next spring to see if we can undo the drought that's in here. But if it doesn't develop, this is going to continue to be the issue. And I would like to show you one last thing. Let's take this back right here to the middle of winter. I'm going to go to Europe. And instead of looking at precipitation, I'd like to look at temperatures. Now, we do know that the European model has a warm bias to it. All right. So when you see white in this area representing near average temperatures, this to me says we do have increased risk, partly because of La Niña, because of the behavior of the ocean temperatures in the North Atlantic, and some of the dialogue we've had lately about the polar vortex, that I think Western Europe is at risk of having substantial shots of longer duration cold weather this winter. And the problem is we have energy security issues through this area right now, and this could really be a volatile move in the energy markets when those colder outbreaks do occur. So these are all the things we're keeping a close eye on right now. But back to what we were discussing, the drought in the United States and the help we could get in reducing this by seeing the development of the subtropical jet. You see, over California, we are right now looking at a pretty serious situation. We've been in one for a while with respect to the reservoirs. Now, these are just the California reservoirs, so you don't see on here like Lake Mead and Lake Powell. But Oroville and Shasta, two of the biggest ones in the north, are still sitting below 35% full pool, which means that development of that subtropical jet is going to be critical to getting this situation to change. We've also seen that lately we've been very dry in the middle part of the country. This is the latest 40 centimeter or 16-inch soil moisture values. And while this has allowed for relatively rapid harvest, we talked about earlier in the week what this is doing to the rivers, the tributaries that all funnel into the Mississippi, and how low the river is right now. Go back to Monday's report if you want to see more about that. Because over the last 30 days, the jet stream has really favored broad ridging in this area. And that's allowed storm systems to really kind of avoid the area. We've gone over very dry again. In fact, over the last 30 days, there are places in Oklahoma, Arkansas, and Mississippi extending over here toward, this part of Kentucky and Tennessee that are right now having their driest 30-day time period when looking at that specific 30 days going back to 130 years. Now, is it going to change? Here's the brief answer. The forecast has been trending a bit drier. Remember how we talked on Monday and Tuesday in the morning videos that we were watching a system early next week? Well, some things have shifted around a bit. And as it stands, we see quite a bit of chances for upper level convergent flow in this area, which produces higher pressure and keeps things drier. That also is that flow around that's going to keep pumping moisture, especially over the next few days, into parts of New Mexico and Texas, adding some late season rain there. But I'll show you why in a few moments the pattern is the way it is. But in the meantime, we are dealing with a big dome of high pressure that's already sinking to the south. And on Monday, I talked about how much dry air was in this. Well, that front just cleared my house. I live right here, and this is where we expect it to be in about 2 hours, sinking through this area here. And tomorrow, it's going to be delivering quite a bit of colder air farther to the south. It's already brought that colder air in across the northern tier of the United States. I was in Fargo yesterday, and they're currently about 30 degrees colder today than they were yesterday. And that colder is going to continue to penetrate farther and farther to the south. In fact, let's get a new update on this map. This is the latest we have from the All Hazards weather map. This is all where we have freeze warnings and frost advisories. This shade of color in through here, as you see, is a freeze watch. So we're expecting this cold air to really extend pretty far to the south. The latest update from the National Digital Forecast Database suggests everywhere in gray that you see in this map will experience a frost at some point through the next 7 days. And for places like this section of Kansas, getting into Missouri, southern Illinois, southern Indiana, Ohio, and then right here in parts of Kentucky, this is an early frost. And there's already been some patchy frost in this area once this year. So I was talking to a couple of growers this morning about that. But this is going to be more widespread as it comes through. Now I'm going to show you temperatures a little bit differently today. We're going to go to the National Blended Model, and I really want you to hone in on this abrupt temperature change in the color change you see in the temperature map. That's where we see sub-freezing temperatures. So as we go into Thursday, so here we are through Thursday. This is tonight, getting into, let's stop at about 6 a.m. tomorrow. You'll notice that the colors here are matching up with something in the low 20s. That's what we're expecting here in the Dakota, stretching up into parts of Saskatchewan and Manitoba. So this is our frost extent tomorrow. Then the temperatures warm back up in the day tomorrow. Then they cool off in the overnight hours. And this is the extent of frost on Saturday morning. Now I want to make a point here that even though there's a hard contour in the data, we will have patchy frost throughout this entire region on that morning, Saturday morning. And then as we go forward, this is how things shape up for Sunday morning. Now on Sunday morning, you notice that you don't see the frost indicator contour anymore, but it's there. There will be quite cold air in this area and patchy frost throughout parts of Kentucky along the Ohio River Valley, butting up against the Appalachian Mountains. So that's the near-term temperature forecast. There's another brisk cold front coming as we go through Monday into Tuesday when the temperatures really try to warm back up. But watch what happens as you get out there toward Wednesday. See the colder air coming in here? Going out to next Thursday, it's pushing back into the upper Midwest and northern plains. And then as we go into next Friday. So it seems that we have 2 end-of-week shots of colder air coming through in the next basically 10 days or so. The reason for that is this block right here. That low cut off from the flow sends systems over the top of it, and they just come diving down, like this one right here, through Alaska, running right through the Canadian prairie. This is next Tuesday, and diving into the eastern half of North America. The big difference between the previous model forecast and this one is what I showed you on Monday, Tuesday, and Wednesday of this week, is that this trough had been forecast to drop like this, but it now progresses a bit farther to the east. And what that's going to do is that's going to change up the ability for it to draw in moisture from the Gulf. It's going to change the temperature pattern, and overall it's going to change the total amount of precipitation we're expecting. Let me show you what I'm talking about. This is today's 12Z European model run. This is this evening, all right? There's the high pressure cell we're watching, the scattered showers out ahead of it, and down here over parts of New Mexico and Texas. So as we play through Friday morning, Friday afternoon and evening, then get our way into Saturday, right in through here, there's going to be some frontogenesis. We're squeezing the air where there is the high pressure to the north and the flow coming around, and that's what's going to be producing that rainfall. But this is that cold morning through much of the Midwest. As we play this through, the low curls up into the eastern side of Canada, and that's on Sunday, getting into next Monday and Tuesday. Did you notice how the rain just kind of stays scattered in this area that whole time? Now, the next system we're watching is right here on Tuesday, but the difference between the latest forecast and the previous was this system was going to dive right down through the spine of the Rockies. This was the one I was watching that was off of China, right? Now it's much farther to the north, and this pressure kink, see the kink in the pressure line there? That's where the next front comes through next Tuesday, going into Wednesday, and then eventually Thursday. Now, could it grab some moisture out of the Gulf and pull it in from Texas all the way wrapping up to the Great Lakes? Sure, it certainly could. And then it spreads that farther to the east here. But overall, we're still pretty far out to know if this wave is going to be capable of doing that. The GFS shows the same thing. I'm going to play it a little quicker for you here, but this is playing through the weekend into early next week. There's the same low. You see it pull the front right here through the Midwest. This is next Wednesday, and then pushes it east. So very similar forecast between the two models. But if we add up the total amount of precipitation, let's play through the weekend first. We're going to pause this out here on Monday morning. That's total accumulated precipitation through Monday morning. So we see how we keep wide open harvest windows despite the frost event. And then as we go out there to next Tuesday, Wednesday, and Thursday, that's when the front passes through and possibly increases the chances for some showers here. But overall, this pattern is still wide open for harvest even out there into week 2, where we continue to see some drier conditions here. And remember, we're waiting for the end of October through the beginning of November for the rains to pick up in the west. Overall, the temperature pattern looks something like this. This is the 5-day sliding window of temperatures as we get out here to the middle of October. And then here's that second shot at colder air coming into the east. The overall pattern is dominated by flow that's doing something like this. Just imagine I'm drawing on the Gulf of Alaska, ridging events here, and troughs that dive in like that. So the west is buying more time. The east is seeing repeated shots at some cooler air, and tucked in the middle are the northern plains, which are going to see some highly volatile temperature patterns. From here, just one last thing to finish up on. Back to South America. Over the next 15 days, we continue to see the models suggesting that Argentina, parts of Paraguay, Uruguay, and southern Brazil, really Rio Grande do Sul, are drier. Expect the planting pace, which we'll get a new update about that tomorrow, to stay high here across Mato Grosso do Sul, over toward Paraná, even down toward Sao Paulo, and this whole region here having great early rains. It's still drier to the east, though. But that drought in Argentina needs to be watched carefully, because when we look back here over the last month, this is September, there's been better rains closer to the Andes Mountains, but from Buenos Aires over toward Cordoba back to Santa Fe along the Paraná River, we've just seen too much in the way of drought, and it's really kind of slowed the progress of planting and caused some issues with the winter wheat crop that's coming out. So we got a lot to be watching here internationally as well. Okay, I'll keep you up to date on this, and we'll talk again next week. Thanks.